Hello, everyone. Thank you so much for joining me tonight. It's going to be a fun conversation. I can talk a lot about cognitive services for hours and hours. So if you have any specific questions or you want me to dive deeper into something specific, please let me know. Write your questions in the chat or when you have a couple of pauses in between, feel free to unmute yourself and ask questions. I'm always happy to chat about machine learning and cognitive services. And today I will be focusing on speech services and we'll be talking how to make your applications interactive with those speech services. And here on this slide, you can see my name, Veronika Kolesnikova, that's me, and my Twitter handle. Feel free to follow me on Twitter. I post some stuff there around machine learning mostly, some Microsoft related stuff as well. Also my schedule when I'm presenting, so you can catch me in person and virtually at different events. You can also find me on LinkedIn, but if you are planning to connect with me on LinkedIn, please, please, please write how you know me and why you want to connect with me, because sometimes on LinkedIn, it's getting a little weird, but it's okay to find me there. So let's start. Bill actually introduced me really well, but here's some more information about me. I'm 4 times Microsoft MVP in AI. I got my master's in information technology, so that was right, spot on. It wasn't from UMass, it was from Clark University in Worcester, Massachusetts. I am currently working as a senior software engineer at Liberty Mutual here in Boston. And I used to work mostly with Microsoft technologies like C#, .NET. I obviously love machine learning and artificial intelligence. I love cross-platform solutions with Xamarin and now switching to Maui. Really excited about that. But recently I also started working more with Node.js and Java, and my hobbies are dancing, traveling, and aerial yoga. So let's move forward with the session itself. And here I want to show you the pyramid of all Azure AI tools that you can use and groups related to machine learning and artificial intelligence. So Azure AI is the huge universe for all kinds of developers, data scientists, project manager, business people, everyone. So I think everyone can find something in that huge universe. And you know that Azure is just endless, and Azure AI is really, really big. And we'll start from the top. On top, we have Azure Machine Learning. So they have, by they, I mean Microsoft, they have a couple of offerings there. Azure Machine Learning is actually a huge portal, kind of similar to Azure portal itself. It is more focused on on actual data scientists and people who are actively working with data, trying to create custom models, doing ML ops, that's DevOps for machine learning. So that's really for people who are hands-on building models from scratch. They have lots of options there, so you don't have to be a data scientist, a professional data scientist, and do you know, those only use Python or only use the Jupyter notebooks. You can actually use UI there where you can create the whole structure right from collecting your data, getting those connections to data sets, and then pre-processing the data, making it ready for machine learning. And then after that, you know, usually actual machine learning specialists, they separate data into training data and then testing data. So you can also use the UI part of the Azure ML if you want to. If you don't want to write code, but you still want to create your models from scratch. But in order to use Azure ML, you do need some knowledge about machine learning and some experience in that area. So it's mostly for professionals in that area. Next, I want to talk about cognitive services. So cognitive services, that's basically for everyone, mostly for developers who would want to include some pieces of machine learning into all kinds of applications because they have APIs, SDKs there. Lots of cognitive services, if not all of them, actually can be used offline, so-called. They can be used inside containers, so they don't have to be online all the time, but they need to have connection once in a while at least to process data. So inside cognitive services, you have something like speech services that we're gonna go and talk more about today. Some vision services like optical character recognition, some object recognition. You can use APIs, SDKs, and so they're available for different languages. You don't need to build anything from scratch. It's all pre-built for you. You're just using the models that Microsoft created and then tested, and they are actually making sure that they are up to date. There are also a couple of opportunities there to customize those pre-built models with your custom data. But you're not building it from scratch. You are basically enhancing that is already there, which is pretty cool. You kind of can be hands-on a little bit, but not building stuff from scratch. So you don't need to know a lot about machine learning and data science, which is really cool. And then next one here is applied AI. So just that is a relatively new category here. They used to lots of those applied AI services. They were part of that cognitive services suite, and then just a couple of years ago, Microsoft actually decided to create a separate group and call them applied AI. What's the difference is that applied AI, they are more focused on scenario-based approaches, and they're covering a wide variety of scenarios, and they're covering them from start to end. So cognitive services, they're more granular, and applied AI services, they're more wider or covering wider options there. And one of the examples there is a form recognizer. So you can recognize the data in different forms and then pull the data out and work with it. So it's from optical character recognition on those forms and then text processing. It covers all of those. Also, decision making can be supported by applied AI, and that is also pretty much full end-to-end solution, which you can obviously customize and also include in all kinds of applications. But decision entails a lot of little steps that are already included into that specific applied AI service for you. So you don't need to worry about that. And the last one here is Power Apps. Power Apps, and specifically put AI Builder, but also they have something like Power Virtual Agent that is also part of AI solution. And I'm sure you heard a lot about Power Apps. Microsoft is actually trying to push the Power Platform solutions a lot recently, maybe the past couple of years. It is really cool that they have those low-code, no-code options for people who don't know how to write code, or maybe they just don't want to write code. And especially if you have team with developers and not developers, and everyone wants to participate and be included, and also participate by providing some benefits to the project. You all can use different tools and then combine them into one solution, or connect different pieces of it together in the end, which is pretty cool. So in Power Apps, it's basically you just drag and drop different widgets there and then connect them. So there you can build your custom. If you use an AI builder, then you can create your custom models. If you're using Power Virtual Agent, you are creating bots without actually writing any code, and then you can deploy them and use on different devices and use anywhere you want, basically. So it's pretty cool. They have options for all kinds of professionals. That's why Azure AI is really cool, and I do recommend checking it out if you have time and you're willing to do that. Okay, so now let's move to the speech services specifically. So speech services, they actually used to be separate little services like bin speech API, translator speech, custom speech, and custom voice. Then later, Microsoft combined all those separate services into one speech service option. So if you go to Azure portal, you can just type speech service, and then you'll get that resource that you can use for all your speech needs. And speech services, they're actually powered by speech technologies used in products like Cortana and Microsoft Office. So Microsoft actually is using those speech services themselves. That means that they are working. They're at least being tested by Microsoft. And so they're safe to use. They're not in preview anymore. So you can use the um, you can use text to speech, speech to text, and then speech translation wherever you want. You can use the APIs, you can use SDKs, you can use containers. There are also options to customize your speech services. There's now the whole speech studio portal, which is kind of cool, and it is kind of similar to Azure portal and similar to a couple of other portals that Microsoft has. They actually now have a bunch of portals. One is I mentioned before that um, uh, the uh, the portal for your Azure ML, where you can customize um, your machine learning models. And then they have special portal for speech services. Also, in the end, I'm going to show you the demo. And part of the demo is that I'm going to use a different cognitive service called LUIS, Language Understanding Intelligence Service. And they have separate portal for LUIS. So there are lots of opportunities for you to customize those services, including speech services. Okay, so now I'm gonna move to speech services features. I personally divided them into three main groups, and then the last group will be customization, so technically four groups, but it is really loosely grouped, just so for you it's easier to go through those features and kind of understand how they're all connected and what are they used for. So the first feature here is speech to text. And speech to text can actually transcribe continuous real-time speech into text. That means that if your users are continuously talking, Maybe it's a meeting, maybe it's a recording of a presentation. Then the service can transcribe that text into speech continuously. And then actually there is an auto fix. So if it transcribed something wrongfully, it actually can go back and fix it based on the context. It actually needs some tweaking here and there because of that, but you can customize it if it doesn't perform well for your scenarios or your specific speeches that you are using. You can use recordings and just feed them to the service, or you can use just mics and people can talk directly to your application, and then your application will pass that information to the speech services and it will transcribe. Then you can use that transcription however you want. You can save it to files and then store somewhere, or you can just use it once and then delete it from memory. So it's totally up to you. It just returns you the text, and then yeah, whatever you want to do with it, it's totally fine. It can not only transcribe continuous speech, it can also transcribe just one phrase. So when you are using speech services for development, then you need to set up that little switch. They have different methods. One method is specifically targeting continuous speech, and another one is specifically for just listening one phrase. Next, it can batch transcribe speech from audio recordings. So I already kind of mentioned that it doesn't have to be real life speech. It can be recordings, especially if you have maybe support services or a call center where you have recordings of all those conversations. It's sometimes really hard to store all those recordings because they are huge. That's why it might be really useful to use speech services and then transcribe those recordings into text. And then the text files, they're easier to store, easier to manipulate in case you want to find something there, do a search. So it's really convenient in that scenario. Next, it can perform pronunciation assessment. So basically, it depends on how your users who are using your application pronounce different words. The service can provide feedback if needed. So if you are using PowerPoint a lot, then you probably saw that now they have those so-called training sessions where you can just practice with your PowerPoint, your presentations, and then PowerPoint will provide you feedback. So that pronunciation assessment there is actually, the speech services are actually being used inside PowerPoint for those purposes. And then next one here, it can call on language understanding intelligence service to derive user intent from transcribed speech. LUIS is awesome. I do recommend using it, especially if you are building bots. It can understand intents. By intent, I mean what your user wants. So it's really important if you're building bots to understand what the user wants, and based on that intent, provide some kind of information or return information, maybe return some links, point the user somewhere, or perform some kind of action there. But LUIS has one thing, and it has to work. It actually works only with text, so it doesn't work with speech directly. So if you are building voice-enabled bot, then you need to transcribe your speech to text before passing it to Lewis. And then Lewis will actually determine the intent. It can also get the entities that you can work with later on. And then based on that information that output from Lewis, you can perform some actions, you can provide some information, and then you can use the speech service again to, if it's some kind of written information, you can use speech services again to convert it to from text to speech. So really cool, especially for bots. Uh, Totally recommend you. And I already mentioned that they have a separate portal, and I'm going to show you how to get there and how to use speech services with Lewis. So next group here is text to speech. Text to speech provides neural text to speech voices, nearly indistinguishable from human speech. I remember I started working with speech services a couple of years ago, and back then there were lots of voices that were close to real human voices, but not too close. So you kind of could hear that something is not right. It's not really a human. And then they had only a couple of neural voices which were really high quality. And then I remember I was showing demo how you compare just regular voice with neural voice. Neural voice definitely was high quality, sometimes indistinguishable from real human voice, which is kind of scary, but it's kind of cool at the same time. So if you want to use natural sounding voices, definitely neural voices are there for you. Now, Microsoft is actually, I just went through their documentation again, maybe a month ago, just to see what updates they made, and they're constantly making updates. So maybe something that I'm telling you today is not 100%, because there were some updates, but I'm sure that most of the things that we're covering tonight, they are still there. So I don't think they're removing things. They're mostly adding things there. And I know they really focused on those neural voices, and now they're pushing everyone to use only neural voices, and they kind of don't really mention those just regular voices, because they have a huge library of neural voices with different genders, different languages. They have so many different options for neural voices that I do recommend you to use those neural voices. They're they're great sounding. And if you actually go to the portal, you can see, you can try some of them. You can see how they all work. They have huge documentation with that list of all the voices that you can use with different genders, with different languages. So really cool. You have lots of options to choose from. And next, it obviously converts text to natural sound and speech. So if you have, if you only have a line of text, or maybe you are converting line by line, or maybe you are getting users input as text and then converting it to speech, it doesn't really matter. You can have whole huge document that you want to convert, or you can have just one phrase or user input that you want to convert. Doesn't matter. You can still use text to speech. And then next one, it can offer multiple genders and or dialects for many supported languages. I already mentioned it when I started talking about neural voices there. So lots of different options for you to try, and they're really good. So again, definitely recommend you to check them out. And the last one here is that it can support plain text input or speech synthesis markup language or SSML. SSML is basically an HTML or XML for speech. Please don't quote me on that. That's my personal interpretation of that, but SSML is not something specific to Microsoft. Actually, it's a standard. So if you are using it somewhere else and then you want to pass that information between maybe different projects or between different tools, and then you're using completely different approaches, that's not a problem. You can use SSML, which can be understood by a lot of different tools and a lot of different APIs and services. Also, it supports plain text input. I already mentioned that before. And SSML, what does it do? It actually can put those emphasis or maybe pauses. So it's not your voice is not just reading it word by word without any emotions. You can actually add some emotions, some pauses there, just using SSML. And yeah, really convenient. So next group here, our feature group, is speech translation. It can translate streaming audio in near real time, which is amazing. If you think about it, I remember when I just started working with speech and speech services specifically, it was a really interesting procedure how you can translate speech to speech. You had your original speech and then you had to transcribe it to text, and then translate the text, and then actually synthesize new speech. So that was really time consuming, it was resource consuming, it wasn't a fun thing to do. Now, if you don't need that text part, translated text, you can just get rid of it and translate speech to speech, which is awesome, saves you lots of resources, it saves you lots of time, especially if you have, as I mentioned here, streaming audio. Then that that option, that getting rid of the text part of there is actually provides you that option to have that near real time translation. And you can translate to different languages. For some of them, you can use dialects. And then since you have access to neural voices, you can use the neural voice to actually synthesize and speak the um, translated translated speech back, which is convenient and it's nice. Okay, so next one, it can also process recorded speech. So it's kind of similar uh, to something that I mentioned in other feature groups. So it doesn't have to be just direct speech through microphone. You can use recordings and then translate them, and then either just um, feed them through your speaker and that's it, don't store it anywhere, or you can save them as files and then have those translated recordings for your future use. Okay, and the last one here is that it can provide results as text or synthesized speech. That's what I was talking about. Um, if you don't need the text part, you don't need to have it. But if you want the text part, you can also have it, especially if you are using something like Lewis, and it might be convenient to have those text options and translated text options, or if you decide to store those translations in text format, that is also an option there. So you can have both text and synthesized speech if you want to. And now it's not real group, but you can have a couple of just separate features that are provided by speech services, like speaker recognition. So you can train your actually all of those kind of in a way are customizations of the speech services, but for those you don't actually need to use the portal. There are actually different layers of customization. You can customize it in just in code, or don't use the portal at all, or you can do more advanced customization through the portal. So speaker recognition, you don't need to use the portal if you don't want to. If you want to, that's fine to use portal there as well. But basically, you can just feed a couple of examples of a person speaking, and then the speech services will be recognizing that's that specific speaker, which is convenient if you have, again, some kind of support line or call services. Then you can determine who is talking, which is really convenient. And then next one is keyword recognition. That might be useful if you are specifically building something for IoT solutions. So there are obviously lots of different examples, but I think IoT comes to my mind first, because you can create a custom keyword, and then it will be not just, hey Alexa, it will be some custom word, like Boston Azure. And then when you mention that word, your IoT device, which is running that solution that uses speech services, can perform some actions, or maybe can turn on and start listening, which is really cool. And then the last one here is voice assistant. So you can use speech services for your voice assistants. Voice assistants, they are pretty much bots, but they are using speech, so they can listen speech, and then they can also respond using speech. That is being used on some devices, like Alexa devices, like, for example, Echo Dot, if you have one, or it doesn't have to be on device. If you have Cortana, then you can create voice assistant skill specifically for Cortana, and then just use it on your computer or your laptop. And now I want to talk a little bit more about the customization options. So you can customize voices, and you also can customize speech. First thing here is that you can create custom phrase list. And for custom phrase list, you also don't need to use Portal. If you don't want to, you can just use code and then provide a list of phrases that your speech services need to recognize, especially if you're working in really specific industries where you have lots of terms that, or maybe abbreviation that they're not being widely used, and then speech services might not recognize those terms or abbreviations. And then if you add those terms and abbreviations, or maybe personal names You can also add them to phrase lists. Then next time when you run your speech services, it will recognize better, and depending on what you do with those phrases, if you are converting them to text or back to speech or translating, it can actually perform better if you are creating those custom phrase lists. Next is speech synthesis markup language. I already mentioned it. SSML, it's basically a standard right now for speech related markups. And yeah, by using SSML, you can definitely customize some emphasis and breakpoints in speech so it can sound more natural. And then keywords and commands. I already kind of mentioned that in my previous slide, that you can create specific keywords, and then if you're combining different services together, then if speech service gets the specific keyword, then it can trigger something or maybe provide some kind of information back. And then also similar, we have commands for similar stuff. And then one of the most interesting and fun things that you can customize is custom neural voice. So it is really exciting that you can create your custom neural voice. For example, if you have a company and then everyone, all your customers, they know voice of your office manager. They're always talking to that person. They're feeling confident that that's the right person they want to talk to. But now you want to kind of create a bot to help that person out. So the person doesn't have to be on the phone just 24/7 and talking to everyone, and you just delegated some of work to a bot, but you want bot to have the same voice so your customers are trusting more the bot. It's a big deal to actually make people trust your bot. But I'm not going to go too deep into bots because I can talk about bots for hours and hours, and we have a lot of content here. So we'll talk about bots next time. Yeah, so going back to the neural voice, using the portal, you can actually upload examples, little recordings of that person's voice saying actually specific phrases, and then you will train a speech service model, which is already created for you, so you don't need to create it from scratch. You're basically just feeding those samples, audio samples, to the model. The model gets trained, and then you can use that custom neural voice anywhere you want. I provided an example with bots. It doesn't have to be a bot. I don't know, any kind of tools you are building with speech services, you can use those custom neural voices. It sounds great to have that option to create custom neural voice. At the same time, it's a little scary because it is sometimes absolutely indistinguishable from real human voice. And, it can be used in different malicious way that people probably don't want their voice to be used. So by providing those samples of audio samples of their voice, the recordings of the voice, actually that person who provides the recordings of their voice, they need to basically sign an agreement. So inside the portal, they actually need to say with their voice that they're agreeing that the voice is being used for that specific custom neural voice. option. And yeah, only based on that permission from actual person, you can start creating custom neural voice. So it's really serious, and Microsoft is taking it really serious. So going back to all those responsible AI principles, I'm glad that they have some barriers, and not everyone can just go and use each other's voices. Otherwise, it will be just chaos, and it's not a good practice to just let AI learn from random voices. So now I want to provide a couple of options from other tech giants like Google and Amazon. They also have similar solutions. I know I'm focusing on Microsoft speech services, but I just want to mention a couple of options from Google and Amazon. So you have options to pick and choose whatever you want, maybe try a couple of things from different providers, and then decide what works better for you. And for each solution, each project, it can be absolutely different combination. You can mix and match. So basically, it's yeah, you can learn more about different approaches and different services from different companies. And before I move with Google, do we have any questions?
Not right now.
Okay. Cool. So let me talk about Google options. So here they also have speech to text services. Speech to text service can recognize more than 125 languages and variants, which is a lot. It can automatically identify spoken language, which Microsoft can also do. I'm not sure how many languages speech to text and cognitive services support. I need to probably dig deeper through the documentation to get that number, but I just don't have it right now. You can also let me know later if you find the exact number so we can compare how many languages and variants Google supports versus Microsoft. And next one here is it can return text transcription in real time for short form or long form audio. That's the same thing as Microsoft is doing. So it can be it can listen for a phrase and then stop listening and transcribe it, or it can continuously listening and transcribing along the way. It can also get the speech from microphone input, or it can get it from recordings. And so the last point here is that it can automatically transcribe proper nouns and context-specific formatting. I think both Microsoft and Amazon, which I'm gonna talk about later, they both do it. So that's basically the standard that everyone is following. Next one here is text to speech option. They have that custom voice option similar to what Microsoft is offering. It is in beta. So if you want to use it here with Google specifically, um, there are some restrictions because it's still in beta. As always, if you're using a tool which is in beta or API, then you need to be careful because it's still work in progress and they're updating a couple of things there. Next, you can access to more than 90 WaveNet voices. Those are mimicking human voices. So those are the same as neural voices. Microsoft calls them neural voices, Google calls them WaveNet voices. And then it can support text and SSML, which is really good. So if you are using both speech services from Microsoft and then Google offerings for text to speech, you can you can pass that SSML back and forth, and both of those will recognize it. And then it can tune pitch and speaking, which is nice to have. Now I want to talk about translation AI option from Google. It supports more than 100 different languages. It can detect language, same as Microsoft. It can translate formatted documents. For some reason, they specifically emphasize on that AutoML translation, which is not something surprising. I think other technical companies that are providing speech translation, they are using AutoML, especially for customization. And so you can create your custom models. You are not building them from scratch. You are basically reusing the models that are already there. You just feed in your custom data. And by using that custom data, those models are being customized, and now they're more focused on specific stuff that you're working with. And they also have extensive list of supported language pairs. And now I want to move to Amazon. Let me grab water real quick. Okay, so Amazon is a little behind. Don't quote me on that. It's not my professional opinion. I haven't worked a lot with Amazon speech services. I know they kind of started later with all or lots of their AI tools. So now I feel like they're a little behind Microsoft and Google. I think Microsoft and Google, they're pretty much on the same level. Amazon is catching up, but now Amazon actually has good options for speech transcription and translating between text and speech, and translating between speech and speech in different languages. And I'll start with Amazon Transcribe. It can add punctuation and formatting to the output text automatically. They decide to emphasize that specifically. I don't think it's a big deal. Everyone is doing it. Next one, you can customize vocabulary and language models. So kind of similar to what Microsoft and Google are offering. Basically those custom phrases that I mentioned when I was talking about speech services, that's pretty much the same. And then they have separate APIs that can understand custom calls. They have specifically Amazon Transcribe call analytics, and then medical conversations, Amazon Transcribe medical. So if you are building those specific solutions for customer calls or medical conversations, then you have separate APIs, which is nice. They've been trained specifically on that kind of information. So whether it's medical information or more customer conversational information, I think it depends what you prefer. You can either use those out of the box options with Amazon, or you can just customize a little more options from Google and Microsoft. So whatever you prefer. And then it can recognize multiple speakers. It can also detect language automatically. And the last one here, it can transcribe audio to text in real time. Amazon has another problem is that it's their documentation is all over the place. I really like the documentation from Microsoft. They have good examples. They have links to GitHub where you can see examples, where you can actually download the repos, I mean, fork the repos, and then run through examples, see how actually it works behind the scene, go through the code, how those services were developed. If you see some bugs, you can go and submit your PR. It's all open source right now. So it's really easy to go through documentation and learn about new tools with Microsoft documentation. They also have Microsoft Learn with videos and lots of information. Amazon, it's really, sometimes it's really hard to find specific information, but I think they're catching up. So if I miss something, about those services, then it was just a problem with documentation. But also it's a problem with me not working a lot with Amazon options for speech services. And next one here is Amazon Translate. It can support translation between more than 75 languages. It adds active custom translation to use customization in parallel with pre-built model. So like those custom phrases that you want to catch, if it doesn't work out of the box, it doesn't recognize something, then you can always add those phrases so it will work better. Then it can automatically identify the language, and it can perform batch and real-time translation. So it can also go through files or just listen through input through mic and then perform that translation. And the last option from Amazon here is Amazon Poly. So Amazon Poly is text to speech option. It has natural sounding voices. They are pretty good quality. They don't actually, I didn't find the list of all the languages that are supported and all the genders. Maybe they do have a list, so if you find a list, please send me. I'll be happy to know more about Amazon Poly and how many natural sounding voices they actually offering. Then they are, have neural voices, so they are still targeting both natural sounding voices, which are a little lower level, and then neural voices, which are kind of human-like sounding voices. You can customize speech output, so you can save to files, or you can just use your speakers, user speakers, to provide the output. And then it can provide storage and redistribution of the output speech files. I don't know why they put it under Amazon Poly specifically, because storage is, I think it's just out of the box with any cloud solutions that you can store in the cloud and then access it from wherever you want. And they also have a SysML support. I mentioned that it is pretty much that standard right now, so everyone supports it, which is really nice. And then it can perform real-time streaming. So it translates from text to speech in basically real time. And now I want to move to the demo.
I have a quick question. Sorry.
Yeah.
Sorry to be that guy, but y'all sound very comparable services in general. When it comes down to pricing, which one is like the I mean that's the bottom line. So in terms of pricing between the Microsoft, the Google, and the Amazon one, how does that work?
Yeah, I anticipated that question, but I honestly don't know the answer. Yeah, I didn't have a chance to compare. I only worked, like specifically worked on real projects with Microsoft Speech Services, and they're relatively pricey, but it depends on how big is your solution. So if you're building like for a project which is really big and you constantly need to go through a lot of text and a lot of transcription, then it actually is money consuming. Bill has some input.
I was going to ask a follow-up question.
Yeah.
I was getting some feedback. Can you hear me now?
Yeah, I can hear you.
Okay. My follow-up question. Well, first of all, I did have I was imagining a comment on the prior question. Amazon, Microsoft, and Google are really good at when they're in a competitive situation. They're really good at looking at the other company's pricing and multiplying by one and offering that pricing. They're very competitive with pricing. So if they have similar offerings, they're probably going to end up having similar pricing. But my question is, so we can have really good voice quality. We can have essentially real-time, on-the-fly translation across languages and creation of transcripts. It sounds like, just looking at some of the highlights from some of the offerings. I'm wondering if any of this requires like super high quality mics or anything like that, or is this just consumer hardware that gets it done?
Yeah, just consumer hardware. I don't have anything specific installed. If you have high quality mics, actually you will want to have high quality mics if you want to do customizations, especially if you want to record your custom neural voice, you want to create it, then it has to be high quality. Other than that, you can use whatever you have. You can use those applications with speech services on all kinds of devices. It can be mobile device, it can be in your laptop, it can be anything. So it doesn't have to be really high quality.
Well, it's we're
I have a little anecdote around
science fiction novel here. It's amazing.
Sean, do you have a question?
Yeah, well, I just have an anecdote about the quality of the cognitive service. This was a few years back. We were using it to tag images, and based on like if it was a person, a face, what object it was, and it came back and just tagged like 2,000 images low res. So like that was the tag, just low res. So just take that how you will. I'm sure it's improved since then, but
yeah, definitely. Okay, so if we don't have any more questions, I can move to the actual demo. I hope you can still see my screen. If you can't, let me know. What I have here is there's a console application. Thank you, Jason. It's just a console application which I created based on some examples online and based on my own imagination, just to showcase how speech services are working, how you can also combine speech service with Lewis, for example, but it doesn't have to be Lewis. I know I talked a lot about Lewis. It can be anything you want. It can be different cognitive service. It doesn't have to be even a cognitive service. It can be applied AI service. It can be any other service from other companies. It can be custom machine learning model. You can mix and match however you want. It is really cool that they provide those options actually. So what I have here is console application. Actually, I was starting using the latest .NET and C# version, and I was surprised that now you don't need to have that main function. But I haven't actively worked with C# for maybe a year or a couple of years. So I was surprised, but I was surprised in a good way that now it's more looking like all those scripting languages that lots of people are using, like TypeScript, Node.js, and stuff like that. But yeah, let's go back to the speech services. So here, just a console application. It provides a couple of options. I have basically 5 demos in one. If you want to check that code yourself after the presentation, I can share the link, or you can just find my GitHub account, and it's just laying there. Nothing crazy about it. My GitHub is a mess, but this one is definitely there. And so here I have that main program screen, and then I have a specific utilities here. Like for example, if I am going to the first option, speech recognition. So I think that's the most straightforward example here. Just recognizes speech. I also created a couple of checks here just to demo what is possible, what you can get out of this speech service, how you can debug it, or how you can actually prevent it from crashing by having, for example, try catch or some kind of error login if you want to. The code itself is not in the perfect shape, so I don't recommend use it as a good example of code writing. That's mostly was created for demoing the speech services. So yeah, speech recognition, I think we are basically using the recognizer here. Speech recognizer that comes from, and let me go there. It is speech recognizer. That's part of the speech services. How I got it there. I have NuGet packages for cognitive services speech, the speech audio, speech intent, translation. You can also have the pronunciation assessment. I kind of commented it out. I don't use it a lot in this demo. And yeah, and also you can have the cognitive services, Lewis, if you want to connect with Lewis. There are also other SDKs for cognitive services that you can use. But now let's go back to the example here. Yeah, basically we're using the configuration here. You need to create a resource. It can be a speech service resource on Azure, or you can just create cognitive services resource, especially if you're using a couple of cognitive services like Lewis, and then speech services, maybe some vision services, and you don't want to manage all those keys, and you need to remember which key is for what, and if you have the key rotation policy, then you need to rotate keys for all those services separately. That's why if you're using a couple of them, you can just create cognitive service resource, and then use the same keys for a bunch of services. And so yeah, using the config, basically I'm getting the keys and region for the speech service resource, and then using the recognizer to recognize the speech. So I'm gonna talk to that console application, and then if it recognizes the text, it will basically transcribe my speech to text, and then return the text. If it doesn't recognize it, then it will return no match. So it doesn't recognize it, then you can start thinking about customization, maybe start with adding custom phrases, so it will recognize them better. And then if something major happened, then you have that result is canceled. So just get canceled, and then you can get the errors and all the details, and you can log them. So let me show you that one. I'm gonna run the demo a couple of times. So let's choose one. Hello, everyone. So we can see here, it recognizes hello, everyone. And then, yeah, I wanted to mention specifically that recognize once async. So that method specifically recognizes only one phrase. You probably remember that I mentioned that it can continuously recognize input from a microphone, or maybe process the whole file of continuous speech. Then you'll use a different method. I think it's recognized continuously, or let's see. You can set up different options there. You can start. So yeah, so for continuous recognition, it's a little more work to set it up, because you need to start continuous recognition, and then you can stop that continuous recognition if you want to force it to stop. Or actually to save you maybe a couple of dollars. If speech service doesn't hear input for a while, it will actually stop listening. But you need to actually control that and make sure that you start listening, you stop listening, you're saving money, but at the same time the service is performing well. So let's go back to, so I also have that example of speech translation from file. I have a WAV file here. Can translate from there. I wanted to talk specifically about speech with intent recognition. Let me go there. So that's the example with Louis. So here I have the speech config, and at the same time I have the Louis settings. So I need Louis ID. I decided to use separate IDs, so I created separately the speech service resource on Azure, and also a separate resource for Louis. I can also show you the Louis portal right here, in case you want to check it later. It's basically, you just go into louis.ai, and then you can create new app right here. And then when you create the app, it will be connected to a specific resource in on Azure. But using the portal, you can obviously work on that app. You can create your custom intents. They have a bunch of intents pre-built, but they're really basic, like cancel, help, and welcome. That translate intent is actually my custom intent that I created. Good part about all those portals that you don't need to write any code. And when I was working on a bot application, it was a skill for virtual assistant. We unfortunately didn't have a lot of people on the team, so my project manager, who wasn't a developer at all, he was using the portal. He liked it a lot because he didn't need to understand anything behind the scene. He was just creating the intents. We obviously had documentation, what intents he needed to create, but it was really really obvious what he needed to add here, and then it automatically actually marked those entities here. I specifically got the text entity and language entity, so I can, when I process them, I can use those entities. So I know that that's the text that I need to translate to that specific language. So let's go back to the code. And so here I'm also using that recognize once. I decided not to show the continuous recognition because it's really really resource consuming, and you need to have a good case to actually implement that continuous recognition, although it's really cool to being able to do that. Same here, I use a bunch of outputs, right? The console outputs right here, so you can see what we're getting. I'm also getting the output right from Lewis, so get result from it. So we can see the JSON that we're getting from Lewis. And then if we get the intent, which is translate, and we are grabbing those two entities that I showed you in the portal. I have two of them, the text and then the language. And then I am specifically translating to that text to that specific language. And then I am, so here it's complaining a lot because I wanted also to show you that little trick that if you want to, again, save a couple of dollars there, and you know that your users probably have that specific language installed on their devices, but you need to be 100% sure that it's there, or actually create a good error management around it. So you can either use the cognitive service, or you can use just the speech, the language that is installed. And if you have that language installed in the system, if your user system, their device actually have that language installed, then you don't need to go back to the cognitive service and then synthesize it from there. You just use installed language, because usually it comes with everything, the text, the speech, and everything when you install it. And then you were just using that one to actually play it. I don't think I have anything installed, so that might be failing right now, but I still want to run it for you, so you at least you see the output that we're getting from Lewis. And then also if something goes wrong, then I also want to show you some errors that can be there. So let's run that option. I think it was 4. Yes, it was 4. So let's run it again. Open to a different screen. Translate mother to German. Yeah, it fails because I don't have German installed and I didn't create that layer of protection that if the device doesn't have the language installed and it goes to speech services. But it can be a good opportunity for me to improve that demo later, or maybe not. It's always good to see what kind of errors we can get. And if we go back to it can go back to the console itself. We see that it actually the speech service itself recognized that I said translate mother to German. Actually, it missed some parts, but it doesn't really matter. And then it passed it to Lewis, and then Lewis recognized the intent. It says translate intent. It's pretty confident that it's that intent. I don't have too many intents there set up, so kind of doesn't really have any options not to recognize it unless it's something completely unrelated to translation. And then it got 2 entities, text, which is mother, and then language, which is German, and then it actually translated. It just couldn't speak it back because I don't have German installed on my machine. So let me just finish with that. Close that. And then I want to show you this one. I think that will be the last one. Again, you can go to my GitHub to check the code and try other examples there. But so this one, I am using the neural voice in English. In this case, it's showing how you can convert text to speech. Again, I am creating speech synthesizer that's part of the cognitive services speech library. And then I am telling it to use the Jenny neural. Also, now they have really cool things like those multilingual neural voices that can actually support several languages. So you can use same voice with different languages, which is really cool. And again, I am getting users' input and then passing it to the synthesizer. And then the synthesizer will just speak the text. Let's run it really quick, and then I'm gonna wrap it up. Oops.
Hello everyone, nice to meet you.
Okay, so I hope you heard it. And you can hear that it's really high quality. Really high quality. It understood the text, translated it to speech. So yeah, I think that's what I wanted to show you. Again, I can talk about cognitive services forever, but I know it might be late and we don't have just all the time in the world today. Yeah, so any questions?
Hi, I have a question. This is Mamadou speaking. I would like to thank you first for the fantastic presentation and demo. So I'm curious about which libraries do you use in your setup? Thank you.
Yeah, good question. So going back here, I'm using the Microsoft Cognitive Services speech, and then speech and speech intent and translation. Sorry. Yeah, so the Microsoft Cognitive Services speech is this speech services SDK. You don't have to use SDK if you don't want to. You can go through the APIs, and here I have a couple of examples with the APIs. Let me find them. They won't be able. Oh yeah, like this one. So I have the endpoint, the speech endpoint, and then I pass in the data straight to the endpoint. And if I'm doing API, I don't have to use SDK.
Thank you.
Andrew's got a question for us too. What kind of device, or i.e. laptop or desktop, do you need to run the code side, or does it run in Azure?
No, so it depends on what kind of application you're building. Sorry. It depends on what kind of application you're building. Here, I just demoed a console application. So it just ran on my local machine. If you're building mobile application, then it's gonna run on the mobile device. IoT solution is gonna run on IoT device. So it depends. Depends on what kind of application you are building, because speech services is just a small part of the application. It's more small, that small machine learning part that you are actually connecting to your application, and you don't need to have a really powerful device to actually run it or to connect to cognitive services. Um, if you are using containers, then the speech services part is going to run on containers. If you're using APIs, then you'll have all those API calls back and forth with Azure. If you are using SDKs, then it goes through the SDK, but you are still connecting to your Azure resource. I hope I answered your question. Good. Okay, any other questions? So yeah, if we don't have any more questions, thank you very much for joining me tonight. Feel free to find me online on Twitter and LinkedIn. If you have any questions later, I'll be happy to help you. I saw that Jason actually shared my GitHub account, which is a mess, but still I have that example, the demo there, so you can check it out. Yeah, that's it. Thank you.
Awesome, thanks.
Yeah, thanks, Veronika, for the brush up. I haven't heard about a lot of this stuff in a while. It's really advanced since last time. Last time I learned about it was probably listening to one of your